Welcome back, everyone. It is AMI Day 21. Mr. Seal here with your science assignment coming from my son's nursery. So today's assignment is all about experiments and those independent and dependent variables and how they're applied to a specific experiment about heart rate. So let's just jump into our reading. Reading goes a little bit like this. How scientists conduct experiments determines if the outcomes can be used or not. Variables are things that can change in an experiment. Some will change and some will need to be kept the same. One variable that is purposefully changed is called the independent variable. This is how scientists test something. It is graphed on the x-axis. This is the variable that the scientist has control over. In your other classes, this would be called the cause. Another variable scientists need to keep track of is the dependent variable. When the independent variable is changed by the scientist, the dependent variable will respond by also changing. In your other classes, this would be called the effect. So we have cause and effect. Scientists graph the dependent variable on the y-axis. There are variables that must never change so the experiment can test one thing at a time. Those variables are to be controlled. Hence, those are called controlled variables. So an independent variable, that's the thing that we're studying. That's the thing that the scientist changes on purpose to see how it affects something else. It's the cause. What gets affected that we're paying attention to is called the dependent variable. The dependent variable is changed because the independent variable is changed. Independent variable always graphed on the x-axis. Dependent variable always graphed on the y. Independent is our cause. Dependent is our effect. Quick example. I take 3 different liquids, water, milk, apple juice, and I put them into the freezer to see how long they freeze. So the thing that I'm changing on purpose is the type of liquid, water, milk, apple juice. The thing that independent variable might affect, my dependent variable, is how much time it takes for them to freeze. Now, there are other things that I would want to keep the same. Those would be my control variables. I would want to make sure that I had the same amount of each liquid. If I had a whole lot more of one of those liquids, that might cause it to take longer to freeze, and that would affect my experiment. So let's take a look at our experiment for today. Our experiment involves the effect of activity on heart rate. And heart rate is being measured in beats per minute. So how many times your heart beats in 1 minute. Okay, so students conducted a controlled experiment 3 different times to find out how walking and running affects their heart rates. So we have one experiment being done 3 times by the students. Okay, so the first student had 70 beats per minute when they were resting. Then after walking, their heart rate went to 90 beats per minute. And then after running, their heart rate went to 115 beats per minute. Student 2 started at 72, went up to 80 when they were walking, and then up to 100 when they were running. Student 3, their heart rate was 80 at rest, 100 at walking, and 120 while they were running. All right. So here are our questions. Question number 1. What is the independent variable in the experiment? So what is the thing that's being changed on purpose? What is the thing that's affecting the other part of the experiment that we're paying attention to? Okay. You might look back up at our title here too to help you out with that. We have a nice diagram, cause and effect, independent variable being the cause and dependent variable being the effect, and where they're graphed. Okay, question 2, what is the dependent variable? So as they change that thing in number 1, your independent variable, what is that affecting? Right? If this is the cause, what is it affecting? Right? What's being measured in our experiment? Okay. Question 3, based on this experiment and what you know about exercising, predict how the student's heart rate would change while they're resting after a long run. Okay, so at the end of this experiment, student 1 finishes the running part and they rest. What is your prediction? What do you think will happen to their heart rate after they run and they just rest? Right? While they're resting, what's going to happen? make a prediction. We don't have the information, so you have to predict. All right, question 4. What guiding question do you believe this experiment might be testing? What is it that they're trying to figure out? What question are these scientists, these student scientists, trying to answer? And the last question, what does the data indicate about the increased physical activity and heart rate? So looking at our data table, what does it tell us about how activity affects heart rate? Okay. Be sure to use a little evidence from the data table to support your answer on 5. Okay. All right, that's all we have for today. Good luck. Hope it goes well. Be a fun one to try out on your own using a watch and just counting your heartbeats. I'll be watching email and Google Classroom if you guys have any questions. As always, miss you guys. Take care.